where Scrum is applicable, where Scrum is not, with a very objective model that I'm going to describe. Right? So let's do this. Let's work on where Scrum is applicable, where Scrum is not. So let me explain you the model first, and then what we will do is we'll get into the exercise about application. All right. The model that I'm going to use here, this model is called as Ralph Stacey Model. Okay, it's called Ralph Stacey Model. Okay, now when I talk about this model, we generally talk about two axes here. Okay, so I'll be drawing the two axes. Y-axis and x-axis. All right, so we're going to talk like this. The y-axis is the what. What means requirements. And the x-axis, how. How means solutions. Now I'll put some signs here. The plus sign means known. Okay, so plus sign means known. And minus sign means unknown. So I'll repeat this word unknown here. So what we are trying to do is, now we are trying to separate out requirements versus solutions, knowns versus unknowns. And I'll give you some examples so that you will realize what this is. Some business problems are here. That means we are talking about known requirements or known solutions. Both are known. This kind of business problem where you know the requirements, you know the solution, these are called simple problems. I don't like the word simple because as soon as I say simple, people think low volume problems. Volume has got nothing to do with simplicity. I like another word. It's called obvious. But I have to use the word simple because that's what Ralph Stacey Model describes. Obvious problems. Okay, so let me give you an example of an obvious problem. And how do we solve an obvious problem? Let's think about it. So first of all, a real life problem I'll give you. All right, okay, so let's say that you and your spouse and you and your friend, whatever, you decide to go out on a driving picnic. So you start driving, start singing, start enjoying the whole nice weather out there. So let's say nice green area there. So you're going there into the nice green area. So I've changed my background to green color. So you start going there and suddenly what happens? Psst. Flat tire. Flat tire. Let me call 911. Let me call roadside assistance, whatever. Unfortunately, no signal on your cell phone. All right. Can you solve this problem now? You can't call 911.
No.
Can you solve this problem?
Yeah, I have to change my.
You have to change your tire, right? So what do? You open your car boot, you take out your spare tire, you take out the equipments, and you loosen the screws, take the car on the jack, take off the flat tire, put the spare tire in, put the screws on, then take the car off the jack, tighten the screws. Don't forget to tighten the screws, okay? And then you take your flat tire and your equipment into the car boot, close your car boot, and driving and singing again. Am I correct? When I described this process in the last 30 seconds, did the whole process come in front of your eyes?
Yeah, I did. Visualization.
So do you see? Requirements are known, solutions are also known. You put it on a set of steps and execute the steps. And the reason why it came in front of your eyes is because that you have done it many times. Known problems, they are solved like this, no? Put a plan, execute it. So what we do here is, it's a plan-driven structure. Create a plan, create a set of steps, execute the steps. So do you see, for a simple problem here, the obvious solution is going to be waterfall. Create a plan, execute the plan. Now let me give you an IT plan, IT project, okay, or IT problem to be solved. Now, many people equate this simple as a word to low volume problem. And that's why I'm going to give you the example of this problem, which is a very high volume problem. Let me rewind your life broadly about 25 years. We are in the year 98, 99. One problem is going to come on the turn of the century. Do you remember what this problem was called?
9/11.
No, not 9/11 problem. It was called
Y2K.
Y2K problem. Year 2000 problem. Yes. Y2K problem. Anybody knows what was the technical issue in the Y2K problem? Obviously, it was a date issue. But anybody knows what was the date issue really?
They ran out of digits.
Why?
None of the operating systems were programmed to have beyond
32-bit.
yeah,
Okay.
that was the thing.
So the whole point here was the year was stored as 2 digits, 2 bytes basically. Year was stored as 2 digits. So only 99 was stored. Now on 1st of January 2000, what was going to happen is because that century part of the year is not stored at all, this 2-digit year 99 is going to get reset to 00. Because the 19 and 20 is not stored. Century is not stored at all. Now do a math. 2000 minus 1999, answer is 1. Do a math between now 00 minus 99. What is the mathematical answer? Minus 99. Now do a greater than and less than. 2000 is greater than 1999. The between 00 and 99, which one is greater? So do you see that is a mathematical issue wherein it is going to throw out a lot of wrong results? It was a known issue. A lot of people think it was a mistake. No, it was not a mistake. It was done intentionally. So in the 80s and 90s, when a lot of systems were designed, the storage was very expensive. It was card storage, tape storage. So it was not only the tape expenses and card expenses, it was a real estate expense of storing those cards and tapes in the real estate. And so the cost of storage was very high. So the thought process was that at this point in time, when the storage cost is so high, let's curtail it by storing only the necessary part in the cards or tapes. And when the time comes, the storage would actually become cheaper. And at that time, we will change it to 4-digit number. That was the whole thought process. And realistically, it happened that way. By the time year 2000 came, hard disk came in and a lot of digital storage started happening instead of tapes and cards and all. And the storage cost really nosedived. And you know what? The problem was actually resolved. I mean, the cost was actually reduced. So the cost of implementing a Y2K was much lesser than the storage cost which would a bank or insurance company would have taken for 10 years. But do you see the problem statement here? It's a simple problem, obvious problem. Set of steps and execute the steps. So you create a set of steps, execute the steps. Do you see the plan-driven structure or waterfall structure works beautifully? In Y2K, there was no Scrum. There was only waterfalls. Plans were made, 2-year plan was made literally, programs were put on the plan, milestones were created, and it was incremental structure. 1 program, 2 program, 3 program, incrementally, program 1, program 2, program 3. Just keep doing, and it was executed to perfection. There is no known Y2K issue which really happened. That Tom Cruise movie about Y2K issue, and that is all a movie. Realistically, in any bank, in insurance company, nothing like Y2K really happened. But a simple problem, solved it by waterfalls. You don't need Scrum for these kind of problems.